everybody. So this section we are covering quadratic functions and models, which for the most of the semester we have talked a lot about quadratic equations and we've gotten into different methods of solving. So this section is not really new material. We're just going to bring it all together to talk about what a quadratic function is and maybe do some word problems towards the end of it. So I just want to start us out with reminding you what the parent function is for the quadratic. All right, so at the very top you see this blank graph, and we're not going to make it exact or anything. We're just going to sketch what y equals x squared looks like. All right, so we should know that that shape is a parabola, and it has a vertex at 0, 0. So it's going to look something along these lines. You have a parent function sheet that I gave you, so please use that as a way to kind of understand the transformations, because we're going to talk about that a little bit today too. So part one, just a quick reminder on how to change forms from standard to vertex form. We do that using the method of completing the square. So completing the square. If you remember anything about completing the square, hopefully it's that you need that little formula for your new c value. So the formula that we're going to need for that is b divided by 2 squared. So what I'm going to do here is I'm going to do one of these problems for you given standard form going into vertex form. And since number 2 is a little bit more complicated, I'm going to do that one with you. So if you remember completing the square, you know that your a value has to be 1. Okay, so number 2 does not have an a value of 1. The a value is 2. Now, when solving, it just goes away. However, this one's going to come back. So just make a note of what a is, because that's going to be very important. All right. So when I start this problem, I'm going to set this equation here equal to 0. My first step is to get rid of a, let a be 1, so I'm going to divide every term by that a value. This will leave me with a new quadratic, x squared minus 6x minus 2. My second step is to get rid of the c value. Excuse me. So what that means is I'm going to add 2 to both sides. That's my old c. I'm going to move it over to make room for my new c. Okay, so remember we left some space on each side for our new c. Going to make room. And to get our new c, we need that formula that I've highlighted up here. Okay, b divided by 2 squared. Now for this particular problem, my b value is -6. Okay, and I get that right here. So when I take -6 and divide it by 2, I should get -3. -3 squared should give me 9. So this is like I'm going to add 9 to both sides. Now, when I go and factor this, the left-hand side is called a perfect square trinomial. So, factoring it should be fairly easy. Just take b and divide it by 2. So this will give me -3, because -6 divided by 2 is -3. On the right-hand side, just combine like terms. Now, if I was solving from here, I would take the square root of both sides and solve for x, but we're not solving. We are moving it to a different form. So I don't want to change the problem, and by dividing by 2 in my first step, I changed that entire equation. So I need to put it back. So I want to put the 2 back right in front where a's typically go. And that's like I'm multiplying the left side by 2, which means I need to multiply the right-hand side by 2 to be fair. Okay, so my new function, I'm just going to write f of x again, is going to be 2 times x minus 3 squared. Now over here was 22 11 times 2. But when I move it to the other side, it becomes negative. So that's negative 22. So this is my function, and it should give me a vertex of 3, negative 22. So when you do number 1, you do not have that issue of a being any other number but 1. But still go through the process of completing the square. Make sure you move all the other terms back to the same side at the end. Okay, so that's how you get your forms. Now, the second part that should also be a review is stating the transformations, and we're going to sketch the graph. Okay, by sketching, the only points that I'm going to care about here are my vertex points. Okay, I know I have a very specific graph with all these ordered pairs, but I'm only going to care about my vertex for sketching. When we get into number 5, if you kind of look further down, that's when we're actually going to graph the entire function without sketching. Okay, so this should be a review. If you need to get out your transformation sheet as a way of reminding you what A, B, H, and K represent, then that's fine. You can do that. But I'm going to do one of these with you. I'll do number 3. So if I look here, I see a negative in front. That should be my A value. When A is negative, that means that I have a reflection over the X value, or the X-axis, I'm sorry. Inside the parentheses, I see that I have an H because it's being added with X. Now, H lies to you, so it looks positive, but it's really a negative 2. And that negative 2 tells me that it's going in the left direction. Okay, I'm going to go left 2 from my parent function. All right, my K value, which is negative 4, tells me that I'm going to go down 4 units. All right, so what we're going to start off with is our parent function, which we kind of graphed at the very beginning. This is y equals x squared. And we are going to perform each of these transformations with reflection first, okay? So when I reflect over x, I'm going to make this a dotted line. It's still going to have the same vertex, but it's now going to be facing downward, okay? Then I'm going to take the graph that I just reflected, okay? So I have this lovely opportunity to just, oh, wrong one, to just move it 2 spaces. So move it to the left, down 4. So this gives me a new vertex of negative 2, negative 4. Right? So you can go ahead and try number 4. I will go ahead and tell you that my graph, it goes off the page a little bit. Don't worry about it. Just practice those transformation skills that we have talked about. And then watch the next video to walk you through how to graph these functions without sketching.